From the silent darkness of space, Venus is a jewel, a serene, pearlescent world, wrapped in a soft, bright blanket of cloud. It's been called Earth's twin, our celestial sister. It's similar in size, in mass, and made of the same stuff. It follows an orbit just next door to our own. From this distance, you could almost imagine gliding through its tranquil skies, looking down on a world perhaps not so different from ours, a world of serene beauty. But this tranquil veil, this mask of placid light, hides a terrible secret. It hides a monster. Because if you were to actually descend through those clouds, that beauty would curdle into a nightmare. The calm would become a tempest, and the light would fade into a suffocating, red-hot gloom. This is no sister to Earth. This is a planetary crime scene. A world hot enough to melt lead, choked by a toxic atmosphere that would crush you flat in an instant. The real mystery of our solar system, isn't it? Is there life on Mars? It's what murdered Venus. What happened to our twin to turn it from a potential paradise into the most scorching, hellish planet in our solar system? The answer isn't just about being close to the sun. The truth is far more terrifying. It's a story of a planet that died, and the evidence of its killer is written in every particle of its poisonous air. The scene of the crime. Before we identify the suspect in this planetary murder mystery, we have to survey the scene of the crime. And to call the surface of Venus hostile is a serious understatement. It's a place that seems engineered by some cosmic force to be the exact opposite of life. We all know Venus is hot, but the numbers are staggering. The average surface temperature is a colossal 467 degrees Celsius, or 872 degrees Fahrenheit. That's not just hot, it's hotter than Mercury, the planet that's literally closest to the sun. At this temperature, lead flows like water, and the ground itself can glow a dull, menacing red in a perpetual twilight. Unlike Earth, there's no relief. A single day on Venus 1, full rotation takes 243 Earth days. That's actually longer than its year, the 225 Earth days it takes to orbit the sun. Yet, while the planet itself turns at a literal crawl, its upper atmosphere is on hyperdrive. Something catastrophic happened. To find the culprit, we need to perform an autopsy, and the first place to look is that thick, choking atmosphere. Winds in the upper cloud layers reach astonishing speeds of 360 kilometers per hour, or 220 miles per hour, circling the entire planet in just 4 Earth days. This superrotation is one of the many enduring mysteries of Venus, a planetary-scale hurricane that never, ever stops. The temperature is brutally uniform across the entire planet from the equator to the poles, from day to night. There is no cool night to offer a break from the oppressive, baking heat. Let's start with the heat. The atmosphere of Venus is a physical force, an invisible ocean pressing down on everything. The pressure there is about 93 times greater than what you feel at sea level on Earth. Standing on the surface of Venus would feel like being almost a full kilometer, or 3,000 feet, beneath our own oceans. Any spacecraft, any person, anything not built like a deep-sea submersible would be imploded, crushed into a pancake of metal and wire in a fraction of a second. The Soviet Venera probes, the only spacecraft to ever successfully land and send back pictures, survived for just minutes before the immense heat and pressure killed them. Then there's the pressure. The air itself is a toxic soup. Forget oxygen. The atmosphere is 96.5% carbon dioxide, a gas we know on Earth for its warming properties, with most of the rest being nitrogen. But it's the clouds that add a uniquely sinister touch. Those beautiful, pearly white clouds we see from space. They aren't made of water, they are thick, swirling banks of concentrated sulfuric acid, one of the most corrosive substances we know. These clouds permanently shroud the planet, ensuring less than 3% of sunlight ever reaches the ground. Imagine a world where the sky is forever overcast. The light is a dim, reddish haze, and it perpetually drizzles, not rain, but acid. Even time is weird on Venus. The planet spins backward, the opposite direction of Earth and most other planets, and it spins incredibly slowly. This is our victim, a world of crushing pressure, toxic air, acid, rain, and an all-encompassing, inescapable heat. It wasn't born this way. Unmasking the killer, every good detective knows, the murder weapon is often found at the scene. In the case of Venus, the weapon isn't just at the scene, it is the scene. The killer is the planet's atmosphere. More specifically, the killer is a phenomenon we're becoming increasingly familiar with here on Earth, a runaway greenhouse effect. Here on Earth, the greenhouse effect is a good thing, a life-giving phenomenon. Our atmosphere has a tiny but crucial amount of greenhouse gases, mainly carbon dioxide, at about 0.04%. These gases act like a thin, breathable blanket. They let sunlight in to warm the planet, and then they trap just enough of the outgoing heat to keep our average temperature at a comfortable 15 degrees Celsius. Without it, Earth would be a frozen, lifeless ball of ice. It leads to the next, more chilling question. How did the killer get so powerful? How did Venus end up with an atmosphere that is almost pure, weaponized carbon dioxide? The answer to that lies in the planet's dark and violent past. Now, let's look at Venus. Its atmosphere isn't a thin blanket. It's an industrial pressure cooker. Remember, its air is over 96% carbon dioxide. Its atmosphere is nearly 100 times more massive than ours. This creates a greenhouse effect of unimaginable power. It's like a one-way mirror. Heat gets in, but it can't get out. The CO2 molecules absorb the outgoing heat and just radiate it right back down to the surface. The heat gets trapped, relentlessly building up over millions of years, until the planet is hundreds of degrees hotter than it should be. This isn't just a greenhouse effect, it's a runaway greenhouse effect. The thermostat is broken, and the furnace is permanently stuck on high. Sunlight still filters through the thick clouds and warms the rocky surface. The surface then tries to cool off by radiating that heat back into space as infrared energy. And here's where the murder plot unfolds. That thick shell of carbon dioxide is almost perfectly opaque to infrared radiation. The sheer efficiency of this heat trap is what makes Venus the hottest planet in the solar system. Even though Mercury is over 50 million kilometers closer to the Sun, Mercury has almost no atmosphere to trap heat, so while its sunny side gets incredibly hot, its night side becomes frigidly cold as the heat radiates straight back into space. Venus, on the other hand, holds onto its heat with a suffocating grip, keeping that steady, lead-melting temperature day and night. This runaway greenhouse effect is the direct cause of the scorching temperatures. It's the undisputed killer. But identifying the killer only deepens the mystery. Peeling back the toxic clouds as we dig deeper, we hit a strange contradiction. The clouds of Venus, those thick layers of sulfuric acid, are highly reflective. They have a high albedo, meaning they bounce about 70% of the sunlight that hits them right back into space. The small amount of sunlight that does get through is trapped with such terrifying efficiency that it completely overpowers the cooling effect of the reflective clouds. It's like trying to cool a blast furnace with a single ice cube. The effect is basically zero. The heat trap is just too perfect. Those super-rotating winds, whipping around the planet faster than the planet itself spins, act like a global convection system. They churn the atmosphere, spreading heat evenly from the sunlit side to the dark side, from the equator to the poles. This is why there are no cool spots on Venus. The entire planet is locked in the same, singular, oppressive temperature. There is no escape. So, if most of the sun's energy is being reflected away, how can the planet possibly be so hot? This is a testament to the sheer, overwhelming power of the runaway greenhouse effect. The structure of the atmosphere itself makes sure this heat is shared with brutal equality. This global circulation also helps maintain the planet's infamous acid clouds. Sulfur dioxide, a gas spewed from volcanoes, rises into the upper atmosphere. There, hit by the sun's ultraviolet light, it reacts with tiny amounts of water vapor to form droplets of concentrated sulfuric acid. They are part of the crime scene's complex machinery. They're a clue that points us downward, toward the surface, and backward, into the planet's history, to a time when things were very, very different. These droplets form the thick clouds that hide the planet, which in turn reflects sunlight and contribute to the planet's bizarre climate. So the very clouds that give Venus its bright, beautiful look are a byproduct of a toxic, volcanic world, and they hide the secret of its unbelievable heat. The backstory, maybe the most shocking revelation in the story of Venus, is that it wasn't always a monster. For a huge part of its history, Venus may have been the closest thing to Earth in the entire solar system. Mounting evidence from computer models and atmospheric analysis suggests that early Venus could have been a temperate, habitable world. Models suggest it could have hosted vast, shallow oceans of liquid water. There might have been rain, continents, maybe even plate tectonics, the same geological engine that drives Earth's continents and recycles its crust. NASA's Goddard Institute for Space Studies ran simulations showing that for billions of years, surface temperatures on Venus may have been similar to Earth's today, maybe even a pleasant 20 degrees Celsius. What cataclysmic event could take a world teeming with oceans and turn it into a bone-dry superheated pressure cooker? This is where the murder mystery takes its darkest turn. The killer, the runaway greenhouse effect, had an accomplice, a trigger event that unleashed it on the unsuspecting planet. It had all the necessary ingredients: a rocky surface, a manageable distance from a young sun, and, most importantly, water. Water is the key. On Earth, our oceans are a fundamental part of our planet's climate control system. They absorb huge amounts of carbon dioxide, which then gets locked away into carbonate rocks like limestone, preventing it from building up in the atmosphere. Water is Earth's great carbon sink. For potentially as long as 2 to 3 billion years, Venus may have had a stable climate. This was the true Earth's twin, a world where, given the right conditions, life could have potentially started. So, if Venus was once a temperate, water-rich world, what on Earth happened? The cataclysm, the transformation of Venus from a potentially habitable world to a hellscape, wasn't a slow, gentle process. It was a planetary catastrophe, a climate change event, so violent and rapid it permanently sterilized the world. The prime suspect for triggering this event is volcanism, but not the kind of volcanism we see on Earth. For reasons we still don't fully understand, huge plumes of magma from deep within the planet's mantle erupted, releasing unbelievable quantities of carbon dioxide into the atmosphere. The planet essentially turned itself inside out, paving over its ancient crust with fresh lava and, in the process, vomiting its interior carbon into the sky. We are talking about massive, planet-wide eruptions on a scale that is almost impossible to imagine. So, as more water vapor filled the atmosphere, it trapped even more heat, which in turn caused the oceans to evaporate even faster. This created a vicious positive feedback loop. More heat led to more steam, which led to more heat. The process became unstoppable. Venus was now in the grip of a runaway. It was the start of the runaway greenhouse effect. On Earth, the water cycle and plate tectonics pull CO2 out of the air and lock it in rocks. Venus lost that ability. The CO2 pumped out by its volcanoes had nowhere to go. It just built up, and up, and up, for hundreds of millions of years, creating the dense, crushing, scorching atmosphere we see today. Venus didn't just lose its oceans. It lost its ability to fight back. It was a complete and total climate collapse. As CO2 levels in the atmosphere shot up, the planet's temperature began to climb. The delicate balance was broken. The final, irreversible blow came from the sun. High in the Venusian atmosphere, intense ultraviolet radiation from the sun blasted the water vapor molecules apart, splitting them into hydrogen and oxygen atoms. The oceans, once a source of stability, now became fuel for the fire. As the planet warmed, the oceans began to evaporate faster and faster. The theory goes that sometime around 700 million years ago, a massive resurfacing event occurred. Over time, it just bled away from Venus, carried off by the solar wind. The oxygen, meanwhile, either escaped as well or combined with carbon to form more carbon dioxide. And with the molten rocks on the superheated surface, with the hydrogen gone, the water could never reform. It was lost forever. This massive injection of CO2 was the trigger. Here's the terrifying part. Water vapor is also an extremely potent greenhouse gas. Eventually, the oceans boiled away completely, leaving the planet with a thick, steamy, superheated atmosphere. But the destruction wasn't over. Hydrogen, being the lightest element, is easily lost to space. This was the point of no return. With its oceans gone and its water lost to space, Venus had no way to regulate the carbon dioxide in its atmosphere. The verdict and the warning, so, the verdict isn't. The case of the murdered planet is solved. Venus wasn't the victim of a single act. It was the victim of a perfect storm of planetary disasters. Its own hyperactive geology triggered the event by flooding the atmosphere with carbon dioxide. This unleashed the killer, a runaway greenhouse effect, which was then supercharged by the planet's own oceans. And finally, the sun delivered the finishing blow, stripping away the planet's water and sealing its fate forever. Looking at Venus is like looking into a distorted mirror, a vision of a potential future. Now, Earth is not in immediate danger of a full Venus-style runaway greenhouse effect. Our greater distance from the sun and our massive liquid oceans give us a substantial buffer. But the fundamental physics are identical. Venus stands as a permanent, terrifying example of what happens when a planet's climate regulation system fails. It is a planetary scale experiment that has already been run, with horrifying results. The key difference between Earth and Venus today can be boiled down to one word: carbon. Both planets have roughly the same amount of it, but on Earth, The vast majority of our carbon is locked safely away in the planet's crust, in the form of rocks and fossil fuels. On Venus, nearly all of that carbon is in the atmosphere, as CO2. Venus is what happens when a planet's entire carbon budget gets released into its sky. This brings us to the most sobering part of this story. It shows us that a planet's climate is not guaranteed to be stable, and that pouring huge quantities of greenhouse gases into an atmosphere can lead to catastrophic, irreversible changes. The story of Venus teaches us that a world that may have once been habitable can be transformed into a literal hell through processes that we are now beginning to understand, and even replicate, on our own world. It serves as a stark and powerful warning. So that bright evening or morning star that we call Venus is more than just a beautiful point of light in our sky. It is a ghost. It's the ghost of a world that might have been, a second Earth that suffered a terrible fate. The hidden truth of why Venus is so scorching isn't just about atmospheric chemistry. It's a planetary murder mystery, a cautionary tale written across an entire world. It's a reminder that the conditions for life are a precious and delicate balance, and that a planet can, indeed, die. So the next time you look up and see that brilliant beacon, remember its story. You aren't just looking at another planet. You are looking at a warning. The culprit was a runaway greenhouse effect, born from the planet's own volcanic fury and sealed by the loss of its water. If you want to keep unraveling the greatest mysteries of our cosmos, from the death of planets to the birth of stars, make sure you subscribe and turn on notifications, so you don't miss our next investigation. And tell us in the comments, what cosmic cold case should we tackle next?